Hello and welcome to another one of these ADD videos. Today we're going to be looking at VESPR theory concept. VESPR stands for Valence Shell Electron Pair Repulsion Model, and that's quite a mouthful, so people just use VESPR. If you say VESPR, everybody knows what you're talking about. And basically what it is it's a useful theoretical model used to predict the molecular shapes. Based on the number of coordinates or domains bonded to your central atom in green, we have what are called electron geometries. You will only really be responsible for up to 6 of them, I believe. So from the electron geometries, depending on the number of lone pairs, we can predict the molecular geometries. Okay, so number of domains or coordinates in red, reddish orange, whatever you want to call that, will give you the electron geometry. And then when we start adding lone pairs, that will give you the molecular geometry. All right, so let's look at the difference. This is the handout available on the website. So here you can tell the whole chart basically depends on the number of domains. And then here, the second column is going to be the number of elements that you actually have. So these are actual bonding domains. Okay, so of the domains, you can either have bonding domains or you can have lone pairs here in red. And the lone pairs, what they do is they alter the basic electron geometry to give you some slight variation of that geometry that has a specific name. So that would be your molecular geometry. So you can see that anytime your number of domains is all accounted for by bonding domains, meaning there's 0 lone pairs, your electron geometry will be the same as your molecular geometry. So 0, linear, linear. 0, trigonal, bipyramidal, trigonal, bipyramidal. Okay? It's only whenever we get numbers of lone pairs that it differs. So looking over here, these are the actual shapes. Let's zoom in a little bit that you will have to memorize, okay? I already went over that fact. The number of lone pairs dictates the molecular geometry. Big point. If you are not really proficient in your Lewis structures, if you can't draw them pretty much automatically, if you're still struggling, go practice. You need a firm grasp on Lewis structures prior to understanding these VESPR geometries. So here we have the actual table that shows us E being the central element, X will be the peripheral elements, and the bond angles. Notice that whenever you have a lone pair present, it decreases the bond angle. Like for instance, in this trigonal planar, when there's no lone pairs, the molecular geometry would also be trigonal planar. But when we add a lone pair, the bond angle that used to be 120 degrees in between each bond angle, or between each element, now gets decreased on the side opposing the lone pair. The reason is that these bonds are formed by electrons. And now I have tagged on electrons here that have a lot bigger density, meaning there's a bigger region which they can be. So therefore they repel these bond angles. And I'll go into more detail when I discuss specific examples how that's working, okay? But just for now, know that the 2 dots are your lone pairs, your X's are your peripheral atoms or elements, and E is your central atom. So you can see that they have different names. Even though all of these are octahedral in their electron geometry, there are 1, 2, 3, 4, and you have to count 0 lone pairs, 5 different molecular geometries. All right? So hopefully you've understood now the difference between what a molecular and electron geometry is. You're going to need to be able to draw a Lewis structure easily so that you can get to the step of drawing the molecular geometry. So I recommend you make some note cards, start memorizing these. If you do 10 minutes a day for 4 times a week, you should have it in a week or 2 tops. If you're doing problems while doing these note cards, it shouldn't take you more than a week. All right? So make sure you check out the different example videos that will go through a few different types of geometries and go in detail on how to actually come up and predict these molecular geometries. So the key is to practice. Check out those example videos. Thank you and have a nice day.